Okay, welcome back, and now we're going to do another example. And in this case here, we've got a rational function, f of x equals x squared divided by 1 minus x squared. And so we're going to go through the 6 steps, and then we're going to graph it. So first thing is the domain. So first thing I noticed that we've got restricted values because we can't have 0 in the denominator, so that means we can't have 1 and negative 1. So that means we're going to have the domain is going to be the set of all x such that x is not equal to plus or minus 1. Okay? So what does it tell us? Well, something's going on. We have vertical asymptotes at those values. So already I know what's going on. Okay? Remember, when the denominator is 0, we have vertical asymptotes. So we'll figure out those behaviors in the next steps. So 2, x and y intercepts. So y intercept, the y-intercept is going to happen when x is 0, which means it's going to be at the origin, 0, 0. And the x-intercept is also at the origin. Zero, 0, because the only way that this function can be equal to 0 is if the numerator is equal to 0, and that's only going to happen when x is 0. So that's all we have for intercepts. Okay, 3, end behavior. Well, as x gets really big positive, so again, we can look at well, we can do a couple things. Remember the degrees of the top and the bottom, right? They're the same, which means that this is going to have a horizontal asymptote at negative 1. Because the leading coefficient is 1 here, the leading coefficient is negative 1. So we're going to have a horizontal asymptote at 1. But you can also see as you take the limit, right? So if you take the limit as x approaches positive infinity, what happens here? This is going to be positive, and you're subtracting a large positive number from 1. And you've got another positive number. So down here it's going to be negative. Right? So here you're going to get infinity over infinity. So remember what we have to do. So we're going to have to divide the top and the bottom by the largest power of the denominator. So that's going to make this one into 1 divided by 1 over x squared minus 1. Now as x goes to positive infinity, what happens? This goes to 0 and this goes to negative 1. And what happens if you go to negative infinity? It's the same thing. So this, remember from before. This, whenever we have this, it's going to be plus or minus infinity. So the limit as x approaches negative infinity of f of x is still going to be negative 1. Because this is still going to go to 0. Whether you're going to positive infinity or negative infinity, it's still going to 0. Okay. So we know we have a horizontal asymptote at y equal to negative 1. And then 4, vertical asymptotes. Okay. We know we have vertical asymptotes at x equals 1 and x equal to negative 1. Those are vertical asymptotes. Okay. Now the question is what happens at the vertical asymptotes? So what happens as we get closer to negative 1 on the left and the right? Okay. So this is where you have to kind of remember, visualize what's going on. So back to this. If I'm getting, let's do this. Is this step 5? I don't think this is step 5 yet. No. So let's come over here. So step 4 continued. Let's look at the limit as x approaches -1 from the left. Okay? As you're approaching -1 from the left, what's happening here? Well, you're putting in a negative number, but it's smaller. And you're squaring it, which is going to give you a small, a number that's small positive, and it's going to be less than 1. Okay? So you're going to get a positive value on the bottom and a positive value on the top. Okay? But the bottom is going towards 0, and the top is going towards 1, which means that this thing is going to go towards positive infinity. And then if you look at the limit as x approaches -1 from the right, well, now you're putting in or hold on a second. No. Let's go back this way. Made a mistake. No, -1. If you're going from the left, you're putting in something that's going to be slightly bigger than 1, because if you're going to the left, you're putting in like -1.01, 1.001, so it's going to be negative, but once you square it, you're going to have something that's positive but bigger than 1. So this is going to be negative, this is going to be positive, so this is going to go to negative infinity. Sorry about that. Now, if you're approaching from the right, then this is going to go to positive infinity, because now you're putting in something that's less than negative or greater than -1, which means it's going to be less than the absolute value of it is going to be less than 1, which means when you square it, you're going to get something that's still less than 1, and you're going to get positive. So it's going to be positive over positive. And so again, this is going to 0, this is going to 1, which means the whole thing is going to positive infinity. Okay, so now we know how it's behaving at -1. Now, what about 1? If I look at the limit as x approaches 1 from the left, now what's going on? Now it's positive 1. Now it's going to be less than 1, right? If I'm approaching from the left, it's going to be less than 1. And if I square it, I still get a number less than 1. So this means this is going to be positive over positive. And so this is going to go to positive infinity. And if I go to positive 1 from the right, well, guess what? It's going to end up being negative infinity. Why? Because now I'm putting something in bigger than 1, slightly bigger than 1. If I square it, I still get something slightly bigger than 1. And I'm going to get something negative on the bottom and positive on top. The bottom is going towards 0. This is going towards 1, so I go to negative infinity. Okay. So now I know at 1, so at x equals 1, it's going to go, or x equals 1, it's going to go from the left, it's going to positive infinity. On the right, it's going to negative infinity. And -1, on the left, it's going to negative infinity. And it's going to positive infinity on the right. So I'm just going to put the arrows there to remind me. Yeah, just want to. Okay, just want to remind me, so I'm going to erase this. Just want to make sure I did the arrows correctly. Okay, now let's go to step 5, and we're going to take the first derivative. Okay, now the first derivative is, remember, the quotient rule, and so the first derivative will be low d high minus high d low Okay, now simplify this. So this is going to be 2x minus 2x cubed plus 2x cubed. So these cancel, and I get 1 minus x squared quantity squared. Okay, good. Now I want to set this equal to 0. So I want to find all the critical values, right? So all the critical values are where I get 0 or undefined. So in this case, I'm going to have a critical value at 0, and I'm also going to have a critical value at plus or minus 1, where it's undefined. And of course, I already know what's going on at plus or minus 1. Okay? So what I'm going to do, and I've already got the behavior, what's going on over here. So over here, as I get close to the asymptotes, I really don't need to really test positive and negative 1 in this case, because I already know it's increasing on the left here, decreasing on the right, decreasing on the left here, increasing on the right. So I don't really need, in this case, to test plus or minus 1. Do so, again, it'd be good practice for you to do that, but I'm just going to test the interval. Now I'm still going to split this up in intervals, but the two intervals, so the intervals that you would split it up into is going to be negative infinity to negative 1, and then negative 1 to 0, and then 0 to positive 1, and then 1 to positive infinity. Okay? But really, all I'm interested in are these two intervals here, because I already know what's going on really here, right? So I'm only interested in what's going on at 0. Okay, so if I put in negative a half, what do I get? If I put in negative 1/2, I'm going to get negative 1 here. I'm going to get a positive number down here. So it's going to be negative divided by positive, which is going to be negative. Okay. If I put in a positive half here, I get positive over positive, which is going to be positive. So it goes from negative to positive. So that means at 0, I have a minimum value, a local minimum. So a local minimum at 0 comma what? Well, that's going to happen at the origin, it looks like. Okay? Okay, so now, let's see, is there anything else I need to know? Okay, so there's a minimum there. Let's see here. Okay. Also, I forgot to mention over here, since we have a horizontal asymptote, one of the questions I mentioned before in an earlier lecture video is we may want to test to see whether this line, whether the graph of this equation, the graph of this function crosses the horizontal asymptote because it could possibly do that. So what I'm going to do is I'm going to set up the function equal to -1 to see if I can solve for it. If I can solve for x, then it means it does intersect the line y equals -1. If I can't, or if I get a false statement, then it doesn't. So I'm going to set up the equation x squared divided by 1 minus x squared is equal to -1, and then see if I can solve it. And so if I multiply both sides by 1 minus x squared, I get the following. So I get x squared equals, now -1 times this will have me switch the two terms. So I'm going to get x squared minus 1. Now if I add, or subtract x squared from both sides, I get 0 equals -1, which is false. So that means I can't solve for x, so that tells me that it does not cross, the graph of the function does not cross y equals -1, so that's good. Okay, so now I also got that information. So let's see here. So again, if I use test points, I know it's increasing here. Or excuse me, hold on. Yeah, so I know it's a -1, it's yeah, so I've got increasing, so yeah, I've got my information here. So from -infinity to -1, it's going to be decreasing. And then here, it's increasing. Or no. Decreasing. Oh, no, I'm sorry. Increasing. Right there. Oh, wait a minute, hold on a second. Why is it? Oh, yeah, I'm sorry, I missed. This is on the left, so yeah, this is correct. Okay. These arrows are just telling me how it's behaving as it gets closer on the left and the right of +1, and on the left and the right of -1. So yeah, so these arrows are meaning something different. But so this is correct. Okay, now second derivative. So now we're going to take the second derivative, so the derivative of this, so we're going to do low d high minus high d low, or yeah. So it's going to be 1 minus x squared times 2 minus high d low, which is going to be 4. Let's see. Plus so 8 8x squared times 1 minus x squared all over 1 minus x squared to the fourth. And then what happens here is this is going to simplify because I can factor out 1 minus x squared. It's going to cancel with one of these. So I'm going to get 1 minus x squared times 2 plus 8x squared over 1 minus x squared to the third. And so I'm going to end up with, well, when I distribute, I'm going to get 2 minus 2x squared plus 8x squared, which is going to give me 6x squared. So this is going to give me plus 6x squared over 1 minus x squared quantity cubed. Okay, so let me just check to see, make sure I did that right. Okay, yes. Okay, so that's correct. Now I'm going to set this equal to 0. And so this is where I'm going to be looking for the inflection points. So the top, well, the top will never equal 0 because I've got x squared here. So there's no number that I'm going to be able to put in to get a negative number. So I'm not going to get 0. So there's no value that's going to give me 0. Oh, excuse me. But the thing is we do have the asymptotes though, remember? So the second derivative is never 0. And also, the second derivative is not undefined for any value, any x in the domain of f. Okay, but we do have the restricted values, plus or minus 1. So we can determine the concavity we'll have to divide the interval into 3 smaller intervals based on the asymptotes. Okay, because it is undefined at those 2. Okay, so what we're going to do is test, since I don't want to. Okay, so let's go back to the 3 intervals. So we're going to test negative infinity to -1. So let's use -2. So if we stick in -2 here, we get +2. So this is going to give us a negative value on the bottom. If we cube it, we're still going to get a negative value. On the top, we're going to get a positive value. So this is going to be negative. So it's going to be concave down from -infinity to -1. Okay? Now, from -1 to +1, so if we plug in 0, what do we get? We get positive over positive. So it's going to be concave up from -1 to 1. And then if we stick in, let's say +2 for the third interval, we'll get, we'll still get a negative, no, we'll still get a negative number on the bottom, positive number on top, so that's going to be concave down, okay? So we know the concavity of those 3 intervals, okay? Now, if we graph this, this is what we get. So I'm going to erase some of this. So look at your notes and let's sketch the graph of this thing. Okay, so let's just put some tick marks here. And now, where are the intercepts? We have one intercept, x-only intercept here. We have asymptotes, right, at -1 and +1. So let's do that. So -1, let's put -3, -5, 1, 3, 5, 1, 3, -1, -3. Okay, so we've got an asymptote here. Let's use a different color. So we've got vertical asymptotes at x equals -1, x equals 1. And then we also have a horizontal asymptote at -1, right? Okay, and we know it does not cross the horizontal asymptote. And so now, since this point isn't here, we know it stays within this area. Okay? Okay. Also, we know it's concave up, and as you go towards -1, we know it goes to positive infinity, and as you go towards +1 in this direction from the right, it goes to positive infinity. Okay, and we know it's increasing on this interval here and decreasing over here. So that tells us that this is going to do something like this. Okay, now, here, what is it up here or is it up here? Or down here? Okay, well, let's use the information that they give us. We know that it's concave down, and as we go towards 1 from this direction, it's going to -infinity. Well, if it's going to -infinity, it's got to be down here. Because it can't cross, as we've already shown, it does not cross the horizontal axis. So guess what? We know it's doing this. And as the end behavior means it's getting closer and closer to this, so we know it has to be doing this, which again is concave down. Here it's concave down as well, but also realize that it's heading towards -infinity as you get closer and closer to -1 from the left. So we know it's doing this, which means it's doing that. Okay? So that's it. So we were able to graph everything just based on those 6 steps and just using reason to figure out what it looks like. Okay? That's it. Have a great day.